All right, hello and welcome to a quick code walkthrough, as well as some brief descriptions of how this all works. This being my PDF Correlator project, which is essentially a doc2vec model from Gensim, a machine learning model that is able to find the similarities between documents. So, first we'll have a look at the directory structure. We have a space for the model data for where it gets saved, a selection of PDFs, as well as a subdirectory, just to show that this program will search from a root directory and through all subsequent subdirectories. One script that gets run later, and here's where the text will get extracted to. And we'll jump straight in, just importing and setting some variables. We'll read the files, so moving through that directory. Again, here I've left in some corrupted PDF files to show the error handling, which basically, if it can't read it, it will just say it can't read it with the name of the file, and just move on. Now we're going to extract the text from the PDFs. First, it tries to do it with PDF2, the package, because it's a lot faster. And if it can't, it will try and do it with PDF Miner, and you can see here that the none PDF was not extractable with PDF2. Tried to do it with PDF Miner, and PDF Miner managed to do it. So now we're going to generate a training corpus from all the text files, which is basically a tagged and tokenized text document that then the doc2vec model can read and interpret. So it iterates through all of these files and pulls the lines from the file and tags and tokenizes it. It's worth to mention that with the doc2vec model, the language that they use to say that it scans a document is a little bit misleading, because it considers a document to be a line of text in a text document. So if you have just a whole document of text that's split by lines, like it normally would be, it would consider every line of that text document to be a unique entity. So now we're going to save that entire corpus that we just tagged and tokenized, and here it is. And you can see it looks a bit like this, which is just a bit of metadata saying that this is a tagged document to the model. Here are the words, and if we were to scroll, to right to the end, you can see that they also have tags. So in this sense, we have 11 tags, because in the text extractions we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 text documents. So we can do a quick little check there that in fact every document was successfully joined into one continuous line, and therefore this model is going to successfully see every PDF as a singular document. So now we're going to build the vocabulary from that training corpus, and then use that to train the model. So that's done. So now the model is trained, so we can save that model for reuse later, or just continue using it within this script. And now we can move on to a way to visualize the data that we have. So if we run this, we'll see some extra files have popped up here, and that is one TSV file, which is all of the vectors of each of those PDFs. So basically, positional data in vector space, and the metadata for those PDFs. This is just some regex substitution, so just getting rid of all of these brackets and quotation marks. Yeah, whatever they're called, single quotation marks, right? Just to make it look a bit prettier. So now we can come over to the what's called projector TensorFlow, loading in the vector data, loading in the metadata, which is the titles, and then we have a visual representation of the similarity relationships between the PDFs that I have trained my model on. Excuse me. So we can see definitely a bit of similarity going on and some dissimilarity. And here we can see very long headings, which isn't very helpful. And yeah, but I can tell you that all of these are to do with technology and virtual reality in specific. And for example, let's have a look. This outlier is, so this is a excerpt from a very large issue of cultural studies. I forget what IAFOR stands for, but it is an article about Islamic mirror tile art. So we can see that it is really creating some dissimilar and similarity relationships here. I can't remember what pwn.0 whatever is, but it's a really good moment to mention that people should give maybe a bit more attention to the title given in the metadata of their PDFs and not just the file name. So now we can do some quick little tests, such as how many times the word internet appears in the corpus, and we can assess the model, which is really just more proof of functionality in my case. Because what this is doing is basically feeding the documents that it has been trained on against itself and saying like, these are new documents, but in fact they're actually already have been analyzed by the model. And so therefore we should expect that a very high self-similar score. So the model should say, hey, these documents are incredibly similar to me because in fact they are from me, but it doesn't know that. But in my case, and as it says in the Gensim documentation, that on such a small corpus that the self-similarity test doesn't really yield such usable values because there's some sort of degree of higher randomization in it when it is trained on such a small amount of data. But what we can do is to check the similarity between an incoming document, much like this did, but in just a different fashion, against the average of the entire corpus. So in this case, I tried to find as dissimilar things as possible, and I found like a Latin generator online. So I generated a ton of Latin text, exported it to PDF, which we'll now read and extract much in the same way as we did before in this walkthrough. And now we can test that against the average of the entire corpus. So it says it's 42% similar, which I don't know enough about linguistics, like how similar just straight Latin text is to straight English. I know they're obviously related. 42%, I don't know, but I think we can infer that there's also a little bit of a effect from the fact that my corpus is so small that it doesn't have enough data to identify how similar or dissimilar this is. I also have a German PDF, which is from Germany, believe it or not. And we can see it's 38%. So yeah, maybe German is a little bit less similar to English, or maybe Latin is a bit more similar to the PDFs in my corpus, which could maybe say something about why it's so difficult for me to understand what I have in there sometimes. But that's a joke for another time, and I would like to thank you for your time of sitting through this. I hope it was useful to understand, and yeah, have a nice day or evening.